Hello and good afternoon, CSI 158, Section 841 and 847 students for the second 8-week term at Anne Arundel Community College in the Cisco Networking Academy curriculum, Routing and Switching Essentials. Today's PacketTracer tutorial is going to be PacketTracer 9.3.2.10, configuring extended ACLs, and this is our first scenario. As you can see here, we have our addressing table, and our objectives are going to be to configure and apply and verify an extended numbered ACL, and then to also configure, apply, and verify an extended named ACL. So 2 employees need access to services provided by the server. PC1 only needs FTP access, while PC2 only needs web access. So both computers are able to ping the server, but not each other. So let's go ahead and jump right in here. And again, this is another fantastic introduction into ACLs, as the PacketTracer activity is going to walk you through each of the steps. So if we were to get onto router 1, and we'll go from user exec mode into privilege exec and then into global config, we're going to go ahead and type in access list, and if you do the question mark at the end, you'll see that it shows the numbers 1 through 99 for a standard access list, and then 100 to 199 for an extended access list. But again, keep in mind that on a whoops, and this is a router here, let me jump onto a switch. On a normal Cisco switch, if I were to exit out here and go into access-list and do a question mark, you can see here that on the regular iOS, we have the first 2 which show in PacketTracer. But then we also have options here for our extended 48-bit MAC address access lists, the expanded range for the standard access lists. There are protocol type access lists. There are IP extended access lists, the expanded range, which is 2000 to 2699. And then 48-bit MAC address access lists, right? And another set of values here from 700 to 799. You can have dynamic extended, and you can also have rate limited. And so again, just to keep in mind that there are many more access list options with the full-blown iOS than you'll see in PacketTracer. Okay, and so let's go ahead and take a look at what we're going to do here. So we're going to choose, again, we're doing a, we're going to go ahead and configure right here is an extended numbered access list. So we'll say 100 because that's the first possible extended access list that you can use. And then if I do the question mark, you'll see that you can do deny, permit, or remark. And so let's see what we have on the regular iOS: deny, dynamic, permit, and remark. So dynamic is an additional option which we don't see here. If I type in permit and then question mark, you can see we've got authentication header protocol, which is used with IPsec. It's part of the protocol suite used with IPsec, along with ESP and SA. And here's ESP, encapsulation security payload. And so let's see what it looks like over here on the regular Cisco iOS. And as you can see, we have a few additional options. ESP, GRE, let's see which ones. So ICMP, so IGMP, the Internet Gateway Message Protocol, right, is another one that you can pick from with the regular iOS. So IP matches, IP NIP for IP tunneling, NOS, which is KA9Q NOS compatible IP over IP tunneling. So we have OSPF PCP, payload compression protocol, PIM, the protocol independent multicast, and then TCP and UDP. So again, a few more options that you want to be aware of on the regular Cisco iOS. Okay, so we did permit with a question mark, so it's going to be TCP, because for this one we're going to do permit FTP and ICMP. And so if I do question mark after TCP, you can see that we can do the source address or any source host if we use any, or we can use the keyword host to indicate a single host. And so here we're going to go ahead and put in the IP address 172.22.34.64. And then if we do the question mark, you can see it's asking for the source wildcard bit. So over here in our instructions, it says notice that you could filter just for PC1 by using the host keyword, or we could allow any host. In this case, any device is allowed that has an address belonging to the 172.22.34.64/27 network. So enter the network address followed by a question mark. And so here's our network address. and we put the question mark in. Now it's going to ask us to calculate the wildcard mask. And so here again is where you would put the actual /27 into binary form with your ones and zeros, and that's the dotted decimal notation here is the 255.255.255.224. And then if I subtract this subnet mask from all 255s or all ones, I would end up with 0.0.0.31. And so let's go ahead and work that in here. So 0.0.0.31. And so real quickly, let's go ahead and take a look. If that was a /27, what about a /28? So a /28 would be, and we're going to go ahead and do it this way, 255.255.255.255, and a /28 would be 255.255.240, and that would be equivalent to a /28. Because again, with a /28, there are only 4 bits that are left over for the hosts. And so what we're doing is we're borrowing 4 bits from the host addresses for network addresses. And so a /28 is going to give you 0.0.0. And if we subtract these two guys out, we get 15. So that would be the wildcard mask for a /28. Let's take a look at a /29. So 255.255. Let's get the dot in there. 255.255, and so that's our all ones for the subnet. And now we're going to put in for a /29. 255.255.255. And you take a look at that. So if it's a 240 here, right? /29 would be 248. That'll be a /29. And so then we'll do our calculation. Some easy subtraction, 0.0.0.7, right? So what's a /30 look like? So we'll end up here, we'll wrap this up with a /30. So 255.255.255.255. Remember the all ones, and we're going to subtract from that 255.255.255. And so for a /30, it would be 252. All right, and a /30 is going to be 0.0.0.3. And so again, this is how you would figure out the wildcard masks, right? So here's my wildcard mask, right? And that would be my wildcard mask. If I have a /30, it would be 0.0.0.3. If I have a /29, it would be 0.0.0.7. If I have a /28, it would be 0.0.0.15. As we can see over here, if you have a /27, it's going to be 0.0.0.31. All right, and so again, just a quick refresher as to how you calculate that wildcard mask. All right, so let's scoot back over to our configuration section. So it wants us to put the question mark at the end, and you can see. So what are we saying here? So we're saying access list 100 permit TCP traffic from the 172.22.34.64/27 network, right? And now we need to determine what are we going to allow, or where are we going to allow that traffic to go. And so as you can see over here, we're actually going to specify the individual host. And let me slide over here, 34.62. You can see the 172.22.34.62 is going to be, let's slide back up, you can see the address table, 34 is going to be the server, right? So 172.22.34.62 will be this server address. And so that server is listed here, but let's take a look and see if that's actually correct. All right, let's take a quick peek here. So let me slide back down. All right, so we're going to say that this network can go to this host, And so 172.22.34.62, and then we'll do a question mark, and you can see here we can pick DSCP, and that's used for quality of service. We can do equals, so match packets on the exact port number, established, which is what we would use for our HTTP connections, greater than, less than, not equal to, precedence, which again is tied in with quality of service in some cases, and range. So we're going to be doing FTP and ICMP. So for our first one, we're going to do equal FTP, right? And so that's going to be the close of that statement. And so I do a question mark. We could do DSCP again, establish precedence. But at this point, we're simply doing FTP. So we're going to create a second access list now. So access list 100, permit ICMP from 172.22.34.64. We already know that the /27 wildcard mask is 0.0.0.31. And going to host 172.22.34.62. Okay, all other traffic is denied by default. And so we've created a single access list, but we've created a second statement, second ACE, access control element inside that access list. Okay, so apply the ACL to the correct, apply the ACL on the correct interface to filter the traffic. So from R1's perspective, and let's slide over here. So from router 1's perspective, and here's router 1, the traffic that ACL 100 applies to is inbound from the network connected to Gigabit Ethernet 0/0. So here's our 172.22.34.64, right? So here's PC1. So that traffic would be considered inbound coming into the interface. Remember that for the traffic to be considered outbound, it would have to enter in one interface on the router, be internally switched inside the router, and then routed out another interface. So if the router has to route and internally switch that packet, then you would want to apply an outbound interface to it at that point after it's already been processed and then internally switched and routed out. That would be your outbound. Inbound is when it's coming into an interface and has not been processed by the router. And by processed, we mean that it hasn't been internally switched and routed inside this router, and then it's coming out a different interface. Okay, so enter the interface configuration mode here. So we're going to go interface Gigabit Ethernet 0/0, and we're going to apply this access group inbound. So 100 in. And so what we're saying is any traffic coming into this interface from this network here is going to have these two ACL statements applied, or this access list 100 with its two ACE entries will be applied to that interface. Okay, so let's verify the configuration. Let me type in, and we'll type write mem to save our configuration. So let's go to PC1, and let's check PC1 here. All right, so desktop, command prompt, and so let's do a quick FTP to 172.22.34.62. All right, and so we are connected to the FTP server, right? And so the username and password are Cisco, and then Cisco, and as you can see, we are connected. All right, so I'll type quit, and now can I ping from PC1 to PC2? Right? And so PC2 sits over here. Let's take a look at PC2's IP address real quick. So PC2's IP is 172.22.34. So 172.22.34.98. And let's not forget the ping command. All right, so destination host unreachable, which means that packet is being filtered by our ACL right here on Gigabit Ethernet 0/0. All right, so let's slide back down. All right, and so that proved that we were able to apply that access list, and it's doing what we expect it to do. So what's interesting here is this this network here, this 172.22.31, and I'm wondering if we're able to take a look at the server to see. Yeah, so it appears that that is a typo. And this is what I was looking at that this didn't reconcile. So the 172.22.31.0, so it says .31.0, but you'll notice our ACL that we created was for .34. And as you can see, the server IP is actually 172.22.34.62. And so that makes me think that this is a typo right here, that this should read 172.22.34.0/26. And so we can further confirm that by hopping onto the router, and then let's take a look at that gig 02 interface. And my guess is yes. So as you can see here, we've got a /26, so this is correct, but the IP is 172.22.34.1. And so this is definitely a typo right here, and this should be .34.0. because our interface here is 172.22.34.1, and we just saw the server IP is a 172.22.34. All right, so take note of that this is a typo right here. Okay, so let's go ahead now and let's work with our extended named ACL. Let me close that down. So which is part 2 of our activity. Okay, so I'm back on router 1. And we're going to work on an extended named ACL. And there you can see there's access list 100. So let's go ahead and go from privilege exec into global config. So this is the one that you would start with IP access list. If we do the question mark, you can see that it's going to be extended or standard. And so if I were to scroll back up here to the top, you can see that we weren't typing in IP before we were typing in access list. So we did an extended, but this was an extended numbered ACL. Now we're going to do an extended named ACL, right? And so we're going to put that IP access list in front of it, or the IP in front of the access list. So IP access list, it's going to be extended. If we do the question mark, you can see here where we can do an extended IP access list number, or I can use a word for the name, and that's what we're really interested in. So HTTP_ only is going to be the name of this extended access list. And so it's going to be a little different. Typically when we configured the extended access list, not the named extended, but just this extended here with number 100, we would type in the entire command, IP access list 100 permit. We typed in all of our from and to information, as well as equal to FTP, right? What application we were using or what protocol. And so here, we're actually going to type in IP access list extended, and then the name of the access list, followed by the return or the enter key. And now you'll see the prompt has changed, because now we're in extended named ACL configuration mode. So now we've entered a sub mode from global config mode, whereas previously when we did the numbered extended ACL, we did not enter into a sub configuration mode for extended ACLs. Okay, in fact, if I scroll back up, we should be able to see we were simply in global config mode, and we were able to type in our extended access list, our numbered extended access list. So again, this is a subtlety here that we are now in a sub configuration mode for extended named ACLs. And so since we've got this access list extended HTTP only, now we type in our permit TCP 172.22.34.96, right? And I'll do a question mark here. And it's looking for a wildcard mask. So again, as you can see, an alternative way to calculate the wildcard mask, and the preferred way, it's much easier than having to write all the binary out, is to simply subtract from the all ones subnet mask, which is all 255s, subtract the actual subnet mask of either the host or the network with which you're working. And so we can see here that ours is going to be similar to what we did over here, right? So that's got to be a /28, okay, because it's a 255, 255, 255.240, and let's come take a look and make sure that's the case. And sure enough, there is that network, and it is a /28. So I'll slide back over here. And so we're going to go ahead and apply that wildcard mask, which is 0.0.0.15. And if we do another question mark, here's where you can pick the host, right? If we're going to do a single destination host, which we are, because we're talking about the www traffic, so it's 172.22.34.62, which is going to be our web server, equal to www. All right, so there's our first statement. You'll notice we're still in extended named ACL subconfiguration mode here. And so then the next statement that we need to enter in is going to permit ICMP traffic, and that's going to be our ping traffic. So permit ICMP, ICMP from 172.22.34.96, and then again the wildcard mask 0.0.0.15, and then the host that we're going to be communicating with is going to be 172.22.34.62. All right. All other traffic is denied. There's an implicit deny at the end. So even if I were to do a do show access lists, right, you can see here's my extended IP access list, 100, our numbered access list, and nowhere at the end of that access list does it say anything about a deny any or deny all. And the same thing here. Extended IP access list with a name, HTTP only. And you can see here we have our statements, permit TCP, permit ICMP, but again, it doesn't show you that there's any kind of a deny any. And so you just need to be aware of the fact that there is an implicit deny all at the end of every ACL statement. Okay, so now we're going to apply this ACL. Let me exit out here. We're going to go to interface gigabit Ethernet 0/1 and IP access group HTTP underscore only inbound. And so from router 1's perspective, we're on the gig 01 interface. So here is the gig 01 interface. And we're saying that traffic coming inbound, so we're concerned about traffic coming from 172.22.34.96. And again, if you take a look at our statement here, that's exactly what we've got with these statements. So we're saying TCP traffic from this network with that wildcard mask going to, right, or source destination. So TCP traffic sourced from this network going to this specific host that's equal to port 80, we're going to permit that traffic. And then the next statement says permit ICMP traffic sourced again from that same network, PC2's network, going to the destination host 172.22.34.62, and this is already says just ICMP, right? So we don't need to do equal anything because we're saying only ICMP traffic or that protocol. All right, so let's apply this access list. I'm going to go ahead and type in. We're going to write mem and save our configuration. So if I do a show run here really quick to close things out, you can see our completion's at 100 out of 100, but we definitely want to confirm what we have here, and we also want to make sure we take a look at validating what we've just applied. So here's IP access group 100 in, and that's what we did in our first extended numbered ACL on gigabit Ethernet 00. Now on gig 01, we have applied IP access group HTTP only, our extended named ACL, and that's also inbound. Okay, and so we've got those ACLs that are there. Let's close the router down, and finally we're going to test our pings here. So it's asking us to ping from PC2 to the server. So we're going to go ahead and ping, and let me make sure PC2 to the server. So the server is 22.34.62. So 172.22.34.62. And remember, we're allowing ICMP traffic through, and so this is going to be successful. And as you can see, it worked great. So if the ping's unsuccessful, verify the IP address before continuing. So we're good there. So now it says FTP from PC2 to the server. And so this should definitely fail. In fact, we'll pull this back up because, again, remember, we're only allowing web traffic and ICMP traffic through. And so what's going to happen is it's simply going to say trying to connect, and then it's going to fail. We've been disconnected from the server. Now, what if I try to ping PC1? Let's see if that works. So ICMP traffic is being allowed through. PC1 is 172.22.34.66. Aha! But we're receiving a destination host unreachable because, again, let's take one more look here. Remember, do a show access lists. Remember that that ICMP traffic is being allowed through, but only when the destination host is the server. And as you can see, we've got 4 matches here. So let's pull this back up. Let me pull PC2 back up because this is a very important point to understand, is that I'm trying to ping, and Windows XP just wants to update. I'm trying to ping over to PC1, and you'll notice it says destination host unreachable because our ACL here, our extended named ACL, is allowing ICMP traffic through from the source network that's PC2. However, it's only allowed to host 172.22.34.62, which we know is the server. And so I can't ping through to anybody except the server. And now let's take a look. So we just ran the ping command, and we have 4 unreachables. And this is the value of the show access lists command, is that typically it will increment every time you run additional pings through that aren't matching. And so you can see here, permit TCP for FTP, there were 11 matches, and then here on the ICMP we have 4 matches. And so if I were to continue to ping through, what you should see is you should see an increment in, and we may not on PacketTracer. So you would see an increment as to the number of matches that you have here that are where it's being allowed through, right? Now, if I was logging my denies, these denies would show up. So let's do a successful ping here. And we know that we can ping through to the server, right? So it's going to go 4 times, and that's going to work. So let's take a look, and there we go. It increments to 8 matches. So if I were to do it again, 1, 2, 3, 4 successes, and then over, whoops, let's do 8. So click over here, and it should show it's incrementing. So this is a good thing because it shows us how many matches we have. So let's go back into that extended IP access list real quick here. So if I type in IP access list, and let's do the question mark, it's going to be extended, and we're going to call, and we're going to do the same one, HTTP_only, and I hit enter. You can see that I'm back in this access list. And so I'm going to add in at the end, deny any. Or actually, let's make sure we're good here. So yeah, let's make sure these are options that are available. Deny IP any. Let's make sure that that's legitimate on PacketTracer. Okay, so deny IP any. So now if I do a do show access lists, right? Now the deny statement, it's not implicit, it's explicitly stated here because I had to manually enter it in. But you can see that it's been listed here. So I want to check something, and let's see with PacketTracer how this works. So if I do a show access lists and I hit enter, you can see we're seeing matches, right? Where matches are hitting, we're seeing those matches. I'm curious to see if we ping back over to PC1 where we get the destination host unreachable. There's no log option. Ah, perfect. Yeah, so there was no log option, but we are seeing the matches here, right? So it is showing us that we've got matches. So if I were to continue to ping over there, and I'm getting destination host unreachable because I'm not supposed to be pinging from PC2 anywhere other than the server, over here, you can see that it's showing me that we've got some activity. So as a network administrator, or from a security perspective, if you have a deny statement set up, and not so much the deny IP any, but if you have a deny statement set up denying maybe PC2 from getting over to PC1, and you see that it's incrementing and it's substantially incrementing, if it's one match, could have been a mistake, could have been a typo. But if you've got thousands of matches, you should probably go talk to the user on PC2 and ask them why they're trying to get to PC1, if that's the connectivity that you're trying to shut down. And so this is good stuff here in PacketTracer because it shows you that we've got matches that are coming in. And so again, from here, let's pull up our web browser. And let's see if I can go to 172.22.34.64. And let's, or 62, I apologize. And let's see if we get any activity here. If there is a web browser, it didn't ask us to do this, but we're just checking here. So let's do the show access list again. And we don't have a match. Yeah, request timeout. Okay, so even though that we were permitting it from PC2, it doesn't look like it's configured to allow that to happen. Let's take a look down at the very end here. And, oh yeah, it should have worked. Open the web browser on PC2, enter the IP address of server in the URL. The connection should be successful. All right, so let's go ahead and first thing we're going to do is let's adjust our deny statement there. So conft IP access list extended HTTP_only, and we're going to say no, right? And if I do the no, I can simply put 30. Right, and because I'm removing this deny IP any here, right? And as you can see, we have quite a few matches now. We're up to 55 matches. So that's typically where you would say, maybe I should investigate what it is that's hitting this ACL, because we should not see matches incrementing like that. All right, so I'll type end, do a quick write mem, and now I'll do show access lists. And as you can see, we did the no 30, and so it removed statement 30. So now we're back here. All right, so let's pull PC2 up, and let's pull the web browser up here, and I should be able to see 172.22.34.62. All right, there we go. So Cisco PacketTracer, what's the image? File not found. Okay, so we're able to hit the World Wide Web over on, or the www protocol, HTTP protocol on the server. And so now let's take another look at show access lists, and we should see, yes, there is a lot of communication going on between something on the PC2 subnet, and in this case we know it's PC2, but we've opened it for the whole subnet, and it's getting to the web server, 172.22.34.62. All right. So remember that this is a typo, right? The 172.22.31. This is definitely should be 34. And hopefully this PacketTracer tutorial has given you a better understanding of extended numbered access control lists and extended named access control lists. We did a few extra steps, right? Just to get a better understanding of why we're seeing matches. And we added in a deny statement even, so that you can see when traffic is not supposed to be allowed, what will happen and what that traffic looks like. Okay, so this has been PacketTracer tutorial 9.3.2.10, and hopefully this has helped you out in your studies. All right, I'll see all of you this week.